Now let's take a look at example 5 of our quadratic and exponential models here. Here we have a drug manufacturer that wants to determine how long a drug will stay in a person. And the amount of drug that stays in the bloodstream of a person is modeled by the equation AT is equal to 35 e to the power t. So here, as you can see, this is an exponential function, and this is the formula that goes. So AT is how much you have left in the person after this number of hours. So the question is, if Jessica took the medicine at 7 a.m., at what time would she have 1 milligram of the medication remaining in her bloodstream? So in this particular case, all what you're trying to do is look, you're trying to when it is 10 a.m., how much would you have left there? So the question is, I have 1 left, and that should be equal to 35 e to the power minus 0.7 times t. So t is what I'm looking for. So there are so many ways of solving this, but for the sake of the SAT and for you to use basic and common sense to solve this, we're not going to go into the mathematics of this. We will just use common sense to do this. So what we want to do is we can plug in the values of t here. T is time elapsed, in essence, how much time has passed since Jessica took the medication. So we're going to try A and C. For A, we hope that 1 will be equal to this after 3 hours, because from 7 a.m. to 10 a.m. is 3 hours. So if you do 35 e to the power negative 0.7 times 3 hours, hopefully that will be equal to 1. Let's try that. So 35, this will be 35 e to the power negative 0.7 times 3. So let's actually bring our calculator and see if you can just do that right here quick. So here you're going to plug in the values. Let's see. Uh, Calculator is a little big here, so let's see. So you're going to plug in the values here. In essence, we have 0, negative 0.7 times 3, and that is equal to this one, negative. And then we're going to take the exponent of that number and then multiply that number by 35. See what we get. That gives a 4.2. So obviously that is not true. Let's go to B. B is 12 noon. 12 noon means we have gone past 12 7. That will be 5 hours. So we're going to use 5 hours. So let's come back here and still play with our calculator here. So we're going to have negative, I'm sorry, let's clean this up here. So we're going to do negative 0.7 times, in this case our t is equal to 5, and that is equal to this. We take the exponent of that, and that is this. Let's multiply that by 35, and that gives us, that is 1.05. So that is close enough. I think approximately we will have 1 milligram of the drug in the bloodstream of Jessica after 5 hours. So here your answer choice is going to be B, 12 noon. So this is how you deal with such problems. So let's recap this quick. All what we are doing is we plug in this, and I think we get 4.2 here, so that is wrong. And then we try B, which is equal to 1 is equal to 35 e to the power negative 0.7 times 5, and that gave us 1.05. So 1 and 0.05 plus equals that. So I think the answer is B then. All right. So this, even though the formula looks, big and it looks funny, you don't have to be afraid. Just plug in the numbers and you should do just fine.